Although 75% of the planet is covered by water, only 3% of that is clean drinkable water, and only a third of that present in rivers, lakes, and atmosphere is accessible for human consumption. The amount of water produced by its natural cycle has remained constant since 1950 and will remain so until 2050. So the amount of water available remains constant while human demand only increases. By 2025, the UN expects that 14% of the world's population will face water scarcity. Graphene. Almost as versatile as water, graphene is a crystalline form of carbon with two-dimensional properties. Its carbon atoms are packed densely in an hexagonal pattern. Lightweight, flexible, almost transparent, and with excellent thermal and electrical conduction properties, graphene is charming scientists. But how do we connect graphene with water scarcity? Well, researchers have been studying the possibility of turning the abundant and almost unlimited seawater into drinkable water with the help of graphene. Graphene filters exhibit exceptional permeability, yet their use for human filter for the purpose of desalination are still quite limited by the permeation cutoff of zero point 0.9 nanometers, which is larger than the diameter of hydrated ions of the common salts. This permeability is dictated by the spacing between the sheets of graphene, which in general for graphene immersed in water is between 1.3 nanometers. Previous work had shown that graphene oxide membranes become slightly swollen when immersed in water, allowing smaller salts like sodium chloride to flow through the pores along with the water molecules. Using a physical confinement method to prevent graphene from swelling and increasing its spacing, Dr. Raul Nair were able to construct a simple scalable method to obtain graphene-based membranes with limited swelling, which exhibit 97 rejection from sodium chloride. It's interesting to observe that decreasing the space between the interlayer from 0.98 nanometers to 0.74 nanometers was possible to decrease the permeability to sodium by 2 orders of magnitude, while water permeability decreased by a factor of 2, and able to filter more salt from water with the same water flow. Now, the challenge is to develop this technology in an industrial way, making possible to produce it in large scale using the minimal amount of energy and decreasing the price per gallon that nowadays are 6 times higher than the traditional ways to produce water. This technology may be the help that humanity needs to face the water scarcity foreseen in your near future.